Good morning, students. In the last class, we have discussed about matter, characteristics of matter, properties of three common states of matter, and latent heat. Let us start today's class with this picture reading. We can see a fisherman is busy and is drying his captured fish. Two people are involved in their regular activity, that is, washing near the riverside and drying up of clothes. Pottery also is there, and pottermen and women are busy in drying up of their articles. The three different activities are under the sun and based on one of the process which we call as evaporation. Evaporation is spontaneous escape of high energy molecules from liquid surface into vapor state, and this is possible because of the random motion of particles of liquid and different amount of kinetic energy. It is a type of vaporization that occurs on the surface of a liquid as it changes into the gaseous state. The liquids locate near the surface, move in the proper direction, and have sufficient kinetic energy to overcome the liquid state. Thus, evaporation is a surface phenomena where high energy molecules of liquid converts into gaseous state. Evaporation causes cooling. Surface molecules absorb heat. This results in increase in kinetic energy of molecules, which then overcome the force of attraction between the particles and escape out as into the gaseous state or water vapors. Decreasing the kinetic energy of the remaining molecules result in cooling. Particles at the surface with higher kinetic energy is able to break away the forces of attraction of other particles and get converted into vapor. Water, when left uncovered, slowly changes into vapor. This results in cooling of various substances around us. Examples of cooling effect of evaporation. The acetone or ether, when placed in the palm, gives us cooling sensation. The surface molecules of acetone absorbs heat. This results in increase in kinetic energy of molecules and overcome force of attraction between the particles. Subsequently, the molecules escape out into gas. The decrease in the kinetic energy of the remaining molecule gives us cooling effect. Second example of cooling effect of evaporation. Sprinkling water on floor or rooftop cools the area. Surface molecules of water absorb heat either from the surrounding or from the surface. Increases kinetic energy of the molecules. Overcome force of attraction between the particles, escape out into gas, decrease the kinetic energy of the remaining molecules, cause the cooling. Third example, the working of air cooler. This gives the cooling effect in the month of May, June, July, August, September. The increase in evaporation increases the cooling. But The same cooler becomes ineffective in the month of August and September because of the suffocation caused due to high humidity present in the air. We used to wear cotton fabrics in summer. Cotton fabrics absorb sweat. This results in evaporation of the sweat through small cotton pores, results in cooling and gives us comfortable. Other applications of evaporation. Industrial applications include many printing and coating processes, recovering of salts from solution, and drying of a variety of materials such as paper, cloth, chemicals, etc. It is helpful in many laboratory analysis such as chromatography. When clothes are hung on laundry line or in dryer, the clothes dry up. Coolers significantly cool a building or a room. The matka or matki is the traditional way to get cool water. Water cycle is driven by the process of evaporation only. Now the two processes. Boiling results in conversion of liquid into the gaseous state. Evaporation also involves with conversion of liquid into gaseous state. But the differences are there which separates boiling and evaporation and give have different phenomena. Boiling occurs at fixed temperature. The boiling point of liquid is essential for boiling process, whereas evaporation occurs at any temperature. It can also occur at room temperature. Boiling is quick process, whereas evaporation slow. Boiling takes place throughout the liquid, whereas evaporation takes place only at the surfaces of the liquid. Bubbles are formed in the liquid when we boil. No bubbles are formed in the liquid during evaporation. Temperature remains constant in boiling, whereas temperature may change during evaporation. Thermal energy is supplied by an energy source, whereas in evaporation, thermal energy is supplied by the surrounding itself. The factors affecting evaporation. Since there are various applications and examples of evaporation around us, we must know what are the factors which affect the process of evaporation. These include temperature, surface area, humidity, and wind speed. Temperature. Increase in temperature is directly proportional to the process of evaporation. The rate of evaporation increases with increase in temperature as it results in increase of kinetic energy of molecules. More surface molecules break down or overcome the force of attraction, escape out as gas. This results in decrease of kinetic energy of remaining molecules and gives cooling effect. Second, surface area. Surface area also is directly proportional to the process of evaporation. Larger the surface area, the more will be the evaporation. The two pictures show difference in surface area of water molecules. In first case, water is in glass. In second picture, it is sprinkled on roof or floor. Less surface area results in less molecules exposed to the temperature, wind, and other condition, and therefore less escape as gas. More surface area, on the other hand, allows more molecules to escape as gas. Third, wind or wind speed, wind velocity. If a day is windy, it results in more evaporation. So, the rate of evaporation also is directly proportional to the velocity of the wind. More wind speed allow more molecules of liquid to escape from the surface and greater rate of evaporation. Humidity. The water vapors present in the atmosphere or in the air is humidity. The more humidity, the less the rate of evaporation. Or, in other words, humidity is inversely proportional to the rate of evaporation. Increase in humidity causes suffocation, does not allow water molecules to escape as gases around us.